Hi, everyone. I'm so blown away that so many of you have come to hear me. And actually, I was supposed to say "Come on, Copenhagen." So yeah, today we'll be talking about testing, and I am going to demonstrate a variety of tools to you, which you will be able to use in any language, and I'll tell you what languages are supported and how stuff works. But I am a gopher, so I write Go, and I am going to demonstrate everything with Go. And for those of you that are not, are there any golfers in the room? Yes, a few people. Well done. Um, so for those of you that are not aware, like the Go community, the people in the Go community are called gophers, and this is our mascot. They've got like teeny tiny arms, and they do funny things, and they can't type on keyboards and stuff. So that's why they're there. So a little bit about me. I'm currently working in the developer relations field, so I go to conferences and I talk about stuff. I've been a Go engineer since 2018, but I started as a Java engineer. I'm a LinkedIn learning instructor, and I wrote a book about test-driven development in Go. And a lot of the ideas that are in this presentation are from the book because I wanted to make them more available to everyone. And also, I grew up and I studied at DTU, which is Technical University of Denmark. So I'm absolutely flabbergasted, so honored to be able to stand on stage here in wonderful Copenhagen. I'm also an organizer of Women Who Go. That's the logo, and it's also on my t-shirt. Women Who Go is a community initiative to help diversity in the Go community. So about only 4% of Go engineers are women, and we want to promote leadership and get people a nicer entry into Go. There are chapters all over the world, but unfortunately there's not a Copenhagen chapter. So if anyone is interested in getting involved and maybe starting a chapter, we can talk about that later. Anyway, that's all about me. So before we go into testing, I want to talk about bugs because testing is a tool to avoid bugs, right? So what percentage of time do you think developers spend fixing bugs? And this is going to be the only audience interaction you'll have to live through. So can I get some votes if you think it's less than a quarter of our time, less than 25%? Very, very, very shy of very few votes. If you think it's between a quarter and half of our time, oh yeah, we're not shy now. There's the majority of people. And if you think it's a whopping more than half of our time, yeah, I see some pain in some eyes here, yeah. Okay, so according to Rollbar, which is an observability company, so I haven't written much down, but I wanted to really do justice to the survey. They did a survey on 950 developers in 2021. And the answers are that 38% of people spend up to a quarter of their time fixing bugs. 26% spend half of their time fixing bugs. And 8% spend more than 3/4 of their time. And my heart really goes out to those people. But the funny thing is also kind of tragic is that 2/3 of the people surveyed said they'd rather do an unpleasant activity than fix bugs. 26% said they'd rather pay their bills. Like, I'd rather pay my bills, get rid of money, than actually fix this bug, which is insane, right? 21% said they'd rather go to the dentist. I feel like that's even sadder. And 20% said they'd rather spend time with their in-laws. I don't know, maybe their in-laws are like really fun. I have no idea. But anyways, we spend a lot of time fixing bugs and we don't like it. So the main tool that we have that we can yield in our hands to stop these things from happening to us that we really don't like is to write tests. And that's why I'm here, to show you the way. But first, let's look at some common bug causes. So these are not the only bug causes, but it's the ones that I've chosen to focus on today. So first, we've got miscommunicated client requirements. Developers are often really far away from the clients. We didn't build the thing they wanted because we didn't understand what they wanted. You've got your poor design and implementation. We've all cut corners. I know it's not something we're proud of, but deadlines come, and sometimes we cut corners and we reuse, we copy some code, and then all of a sudden bugs happen. You have insufficient testing, so we know that we should be aiming on 80% test coverage, but again, things happen and we gotta get things out the door, and most of the time it's the tests that get the boot. Then you've got, even if you do everything right, you still can have functionality regressions, because maybe someone wanted to introduce something new and then they ended up breaking your little like baby feature that you nurtured and put in production. And you could also have the problems from inside the house. So incompatible dependency API changes. Someone changed an API that you really trusted and they didn't tell you, because why would they? Or the code can be coming from inside the house and you've got unexpected changes inside the system. In a microservice architecture where you don't know what team B is doing, these things could happen. So we often talk about the software development lifecycle, and this was like one of the things that came along with the DevOps movement. And what we see is these things that I mentioned are riddled throughout the software development lifecycle, so they can happen at any time. Especially, what I think is really jarring and is something that's very difficult to detect is when things go wrong without you touching them. So past the release and the maintenance. After you've tested them, the API changes can happen from under you. So all sorts of things can happen even if you think you've done everything right. What does this point to? Better testing strategies. There's another very famous IBM study from 2001. Take it with a little grain of salt, because obviously we deliver software in a very different way now. But they say that the cost of fixing a bug goes to a whopping 100 times more, 100 times more expensive when you fix it and past the test phase. So if it costs 1 to fix it on the design phase, it will cost 7 at implementation, 14 in the test phase, and a whopping 100 in maintenance. This was one of the mottos, one of the reasons that the DevOps movement said detect early, detect often. And we talk about the shift left of testing, so test earlier in the development pipeline. So again, this is difficult because our bugs are happening all across the development pipeline, and it points to having some kind of automated way that'll like monitor when things really go wrong, and they will protect us. We need automation to protect us from the unknown. But not all is lost. Why? Because engineers are now involved throughout the development pipeline, like the DevOps pipeline. Even if you have SREs, they're mostly still working with engineers that are delivering features, delivering functionality. You see this interdisciplinary kind of team makeup where everyone can work together, detect bugs, and fix them. So yeah, I mean, that sounds pretty good, right? When we talk about tests, we talk about the testing pyramid. And I'm not going to spend too much time here because we all kind of know it. So you've got a unit test. Why is the pyramid wide at the bottom? Because that's the most amount of tests they should be writing. So you've got unit tests, which should be the most numerous, integration tests, which are less numerous in the middle, and end-to-end tests, which are at the top. Integration tests are particularly interesting because they allow us to test how things work together. We talk about the seams of units and the integrations between units that are perhaps working correctly, but do they work well together? And this is where integration tests really shine. I don't know if many of you have seen this, but there's been in 2008, 2009, there's been a revision on the unit testing pyramid, and we call this the testing trophy. Why? Because writing test code is real code. So I'm going to say that the reason I say that is because once you put some tests out there, you got to maintain them. And this can make it more difficult. They kind of like build walls around your software, and it becomes more difficult to change your software. Why? Because now you got to go and you got to refactor all of your tests and make sure that everything is working. At the bottom of the testing trophy, we have static checks. And why do we like static checks? Because they're normally built into the language and you don't have to make them and maintain them. The static checks that we talk about are reviews, you've got static analysis, check style, you've got linters. Most languages will provide these, but of course, Go particularly shines in its tooling. Yeah, one of the reasons why we should love Go. When we talk about code coverage, we're still talking about the 80-90% range, but we notice that the integration tests are more numerous. Why? Because with using compilers, with like checks, for example, Go is able to check dead code. We've got a lot of tooling that can help us. We don't want to spend time writing unit tests that are just getters and setters. Instead, we should focus on these seams between units where bugs really like to burrow and thrive. Okay, so let's talk about microservices. I've covered the basics. We know that integration tests are better, are really important, and we're going to move away from unit tests, which are the bread and butter of engineers. So microservices, we know that one of the main things that they deliver is the ability to change systems faster. Why? Because we can deliver changes and release them at different times without central oversight. That's one of the beauties of microservice architectures. We don't have to build these humongous binaries and then deliver them. When we look at the way that two services might interact, we talk about direct API calls. One requests some information and the other responds. Or you can have it with a message queue, and in that case, we have event-driven architecture. But what can go wrong? I'm always like really nagging and like, oh, what can go wrong? So when it comes to direct API calls, you can have request and response format issues. You can have incorrect service behavior. So even if service B seems to be passing tests and seems to be working correctly, it might still not behave according to the expectations of service A, which is then a humongous problem. In the event-driven architecture, we've got the same issues. We've got payloads. Even if the response is an event payload, it can still be wrong. We might still not be able to parse it. Then, of course, you've got brokers. So for those maybe not familiar with event-driven architectures, brokers are the ones that manage message queues, and they are able to store messages until the receiver is ready to take them on. And often you can also have events acknowledged but not processed. So things just keep going wrong, and there's no getting around it. We need to up our game and write more than just unit tests. So I hope this has laid the foundation of what I'm going to talk to you about. When we talk about, so let's start pulling the testing lever. I've talked enough. Let's see some action here. When we talk about testing, we talk about test-driven development, and this is the flow. You write test code first, you see it fail, and then you write implementation code, and then you see the test pass, and you do this like wonderful, elegant dance where you assert the logic of the unit under test. Even though my book is about test-driven development, and I believe that writing tests is obviously very valuable, I'm not like a die-hard TDD practitioner, because I think sometimes we don't think in fractions. We don't think in if statements and then a little bit. Like, we think in bigger blocks, and our thoughts are more abstract than a little tiny piece of functionality that you'll write and then go test immediately. So honestly, I don't really mind if you use TDD as long as you test correctly and you make testing part of your practice and something that you like internalize, that quality is something you care about. Yeah, so I'm probably gonna, if you at me online, I'm sure the TDD people will go mental. In Go, so this is where I start to show you Go. In Go, packages are the smallest unit under test, and they are what we call a self-contained mini API. The only things that you're able to see inside, so the only thing that you're able to see outside of package scope is something called exported names. There's no public modifiers. The only way you know that something is exported is because it's capitalized. Ooh. So when I capitalize something, that's the equivalent of me making it public. Tests in Go are just functions, and we declare functions with the func keyword. And tests must start with, they must have the signature, which is the, as you see, test hello. So they start with the capital test, and then we camel case the rest of whatever. And they must take a single testing T parameter. What you see there, you see something really funny. There is a little star in front of testing T. Pointers are explicit in Go. A lot of people get kind of annoyed, but due to memory, Go was made to be very, very fast. And when you are able to handle your pointers explicitly, you can make really performant code. What we then see is I start by declaring an array of names. We've got Anna and Bell. Then we for loop over these two inputs, and we're going to run two tests. The t.run that you see here is my way of creating subtests, which are kind of like like me building a mini test suite. And then you're able to write these tests that can execute over a variety of inputs. So that's it. I mean, testing is pretty easy there. Oh, if something goes wrong, then we call the t.fatal and say like, hey, this suite is going to stop because this is the end of the world, and we're going to cut the whole test run. So I know it seems kind of like weird, but it's my job in life to show people Go code. So now you've seen it. Another cool thing that we talk about when we talk about testing in Go is fuzz testing. So fuzz testing is a little bit different, but it generates a corpus, what we call a corpus of values from a starting seed. You can do that in in other languages as well, but it was recently introduced in Go. And what happens is that I don't have to write Annabelle, Clarice, Diane. We can begin to generate a large variety of inputs and cover and find edge cases. The way they work is they start with the keyword fuzz, and then they take a different parameter, which is the testing.f. Then instead of running it, you call fuzz. And at that point, the fuzzer, what we call the Go fuzzer, will begin to generate a huge amount of inputs. It helps us to ensure code robustness inside our unit. And what do we mean by code robustness? Is how do we handle completely unexpected inputs? For example, let's say that instead of Anna and Bell, I've got some non-Unicode characters. Even in my little teeny tiny say hello function, a whole bunch of stuff can go wrong, and this is where fuzzing really shines. So I know I wanted to take you above unit tests, but I really wanted to show you fuzz testing because it is very important also in security testing. So fuzz tests are really a great fit for testing any kind of user input that you don't trust, and you should never trust the user input, right? Even if it's coming for your trusted friend's third-party APIs. Okay, so I'm going to show you a little bit more Go code. I've built a super useful conference talks service. We're going to interact with it as a client, and the server exposes 3 endpoints: events, and by ID. So I've built like the little teeny tiny REST API, and even in this thing that doesn't have any other third-party service, it doesn't save any data, I'm going to show you we can get in some serious trouble, and we can write some really interesting tests. What it does is it saves some events. So here we have Copenhagen Devfest, and then you can list all of the talks that are from this event, and it allows us to, maybe just like filter through talks and they're in a particular day. So let's see the code. So all of the code that I show you is available on GitHub. Testing Strategies Demo and Adet is my username. The slides will also be there, by the way. So if you want to check out the slides, you can do that. Maybe because you particularly like purple and pink. Anyways, so first I'm going to show you the event. So the way we do JSON tags is with these backslashes. So this is the structs. Structs are custom types. By the way, Go is not object-oriented. We can talk about that later. So we have these custom types called talks, and then talks belong to events. So I've built just this little thing. In the event service, oops, 2 seconds. In the event service, I save events inside a map. Maps are dictionaries, like you might know them as dictionaries in Go. And then when we pass an ID, we just simply fetch it from the map. And if we don't find one, we return a nil. So, you know, we have nils because we've got pointers. When I test the event, when I test just this little, sorry about that. When I test just this little tiny function, I'm going to write a test that does a variety of inputs. And the way we do that is I set up an array exactly like we saw with Anna and Belle. Then talks belong to different events. I initialize the event service, and then I run different subtests exactly like we saw before. So if I were to run this test, so you write go test, and then in order to run all of the tests in your suite, you do this little thing which says traverse all the directories and find all of the tests. And then I'm going to do -v, which means verbose, so we can see all of the output. Also, how funny would it be if tests failed? So what we see here, these are the subtests that I was talking about. You see, for example, test, get, event, filter, talks, and then we've got subtests that are nested underneath it. You could do the same with Java and suites, I suppose, but the cool thing about this kind of output is that you can see exactly what ran and what didn't, what passed and what didn't pass. I want to show you the fuzz testing as well. So what I'm going to use as my fuzz target is the talk title, because we talked about that there could be all sorts of like random characters and what will we do. So I create a new talk. The name is going to be the target. And then I do the exact same kind of assertions that we saw before. Save the event. Can I fetch it back? And is it correct? Now, fuzz tests will run until they fail. So that means that if you have a function that says assert that returns true, you could end up running forever, right? So what we do is they will run until you fail, you panic, or there's like, or it runs out of time. There we go. So in order to, I'm going to click this. So I've got a little cheat sheet here. So in order to test it, we get go test. And then the -fuzz allows me to say, like, listen, this is the test I want. So my test was called fuzz get event. Then I can say, okay, I want to run it for a particular time because I know my code is perfect. So I'm going to specify fuzz time as 5 seconds. Ooh, sorry about that. 5s, and then it is going to live in the data folder. So I won't run everything this time. So this is how I can say run this particular thing. What's happening now is we're gathering a baseline. We're running over multiple workers, and actually we executed this many test inputs. So you see, this makes it so easy for us to test with a variety. Like, imagine if I had to generate all of these inputs. A, I'm really lazy, so I don't want to do that. And B, I'll probably get it wrong because generating true randomness is really difficult. The Go fuzzer will also try and catch you out. So they'll be like, they find what are called interesting targets. So they'll try and generate a wide variety of things and then find a failure. So I think this is also really interesting. If, let's say, your service is written in another language and you wanted to make use of the fuzzer, you could still do that, and you can fuzz inputs and outputs at any point. Okay, I hope that has whetted your appetite when it comes to testing. But unfortunately, I still spent all this time talking about unit tests, and I promised you more. Well, I will deliver. Okay, so when we talk, so let's move up the test pyramid, right? Okay, let's talk a little bit about the difference between integration tests and end-to-end tests. To my great shame, I was confused about them, and I kind of used them interchangeably for a little while when I was quite junior. So I thought it would be useful to talk about what they are. So integration tests are all about testing a particular, well, we don't talk about units anymore, we talk about components, so self-standing components that have a defined input-output relationship, while end-to-end tests test user flow and user experience. The reason why end-to-end tests get a really bad rap is because they are slow and expensive. The reason why they are slow is because we need to start the whole application and end-to-end, right? Like that's the whole thing. If integration tests are a good middle ground, and also why they were the biggest part of the testing trophy, because they allow us to test larger scope while not incurring the cost, correct? We can perform, the timing is crucial. We saw how much costs soar the longer we wait to test. So the integration tests have the advantage that they can be performed earlier in the software development lifecycle. But end-to-end tests should not be thrown away. Why? Because they test what our users will eventually see. And finally, the scope is that integration tests ensure that their component works as intended. Their component brings together multiple units, and it tests these integration seams, while end-to-end tests have this like more workflow kind of focus. So yeah, I hope that has cleared up anything that we didn't know. In Go, we have the HTTP test library, which I can't wait to show you. The reason why we really like it is because when we write tests with HTTP test, we use the same code as a client will. So we interact with the HTTP library, which is the default way we write client code. This is huge, in my opinion, and I think you will agree too. It's huge because our tests can be the first consumers of our service, of our API, of our response. We can really get in and see how does it behave, what should the people that depend on my service expect. Another cool thing that it does is it starts a mini test server under the hood, so I can pass a thing called a handler. So the handler is the one that takes over HTTP requests and builds responses and status codes. Another cool one is this, when we talk about, so HTTP test is important in the world of integration tests, which we know is super important. In the world of end-to-end tests, we have the test containers project. So HTTP test, I should have mentioned, is part of the Go standard library, while test containers is an open source project. And this test containers is super cool. Why? Because it bundles together container management with your test code. And why is that cool? Because you don't have to manage starting up a server, waiting for like a health endpoint. All of this is taken care of for you. And where it really, really shines is when you have dependencies on other containers as well. You can encode that into your test and make it easier for you to write end-to-end tests. And it makes me really excited because I don't like to write anything other than Go. I don't like to write, some other script that'll wait for things and then return stuff or write the file or anything like that. So I think this test containers project is really a game changer for me. You can see here the languages that it supports, and obviously we are obsessed with Go today, so it's going to be all about Go. The team are really lovely, so if you want to build support for another language and you want to get involved with open source, they will help you as well. Okay, should we see some more code? I think so. I mean, that's kind of why we're here, right? Oops. Okay, so what is a good candidate for integration testing? Well, they are our handlers. So I'm just going to show you a very quick handler. So the event handler we'll call the event service. and get things, get the events that are according to that request, that are according to like the endpoint or the request that what they wanted, and then we will build an HTTP response. Again, we do this with the HTTP library, and then we can return responses and bad requests and all of that. When it comes to testing it, what I want to do, so integration tests are faster than unit tests, my apologies, than end-to-end tests, but I still might not want to run them on everything. So what we usually do, we need some kind of separation. What's an integration test? What's a unit test? Because really they are just tests when it comes to like the lens that, the way that Go registers them. So the way there are a few options, but the way I've done it is with an environment variable. So this is what I do here on line 63, where if the integration environment variable is not set, then I skip this test. And why is that important? Because you want to give your developers a feedback loop that is as quick as possible. So maybe I don't want to run all of the integration tests when I'm testing just locally because, you know, for reasons that I don't want to. Then we write the test cases and set up everything in exactly the same way. In this particular example that I wanted to show you, what we also have is something called table-driven design. So table-driven testing. So table-driven testing allows us to build a map of expected of input, which is my event ID, and expected response. And this is what I've built here. Why this is a very popular testing technique in Go because it can be really easy to add new inputs and outputs. So you can add a new test case really easy. What we do here is we just loop over, and in the case, so some are failures and some are passes. So in this would be like a successful test case. This is how we handle it. And then in the event of a failure test, of a failure case, which is also super important, you should test your failure cases. I should have said that as well. Then we do some other code. The way that we interact with HTTP test is we use this, we set up a recorder, we set up a request here on line 121, and then under the hood, the ephemeral test server that I was talking about is here on line 124, where you say serve this HTTP. And that's all we do. The way we run that is in the usual way, but I need to set this environment variable that we spoke about. And one cool thing that the Go toolchain can do is we can set an environment variable just for the scope of a single Go test command. So the Go toolchain supports other commands other than test, but obviously like this is what we're doing today. So I'm gonna go say Go test. The tests that I want to run are in the handlers folder, so I'm gonna say that, and then I'm gonna say verbose as well. So now I'm going to run all of the integration tests, and this is what comes out. Again, they run quite quick, but actually like 0.6 seconds is quite a lot. So this is why the reason why I want to skip them when I'm doing my quick feedback loops. I'm going to show you really quick because I'm really keen on this test containers project to show you what it looks like. So way I do is these expected events are in the same way that we've done it before. So the way that I instruct test containers to run something is with this container request that you see on line 47. And then I give it an image that I've put on Docker Hub. So I've built the image of my server that I want to test on, and I've pushed it to Docker Hub. And then I say listen on this port of, obviously I've hard-coded some things because I'm doing demos, but you shouldn't hard-code ports in this way. Then it starts up this generic container, and once the container is up, then we will be able to pass to the next part of the test. Deferred functions are functions that are like cleanup functions in Go. They go at the end of the test. And here I say at the end of my test, please terminate my container and clean things up for me. Obviously, I don't want things to like just, you know, live there forever. Then we are returned an endpoint. So this endpoint will be coming from your server container. I don't control it. It's generated by test containers. And then all of the rest of the test is done exactly like an integration test. We use the HTTP library to be able to interact with the ephemeral container. This is actually going to be a more exciting this is going to be a more exciting test run. I didn't show you, but I've got another environment variable which is called E2E, because again, I want to separate my test with, I want to say like exactly what I want to run when I want to run it. So here I say go test. Where is it? In the E2E repository, in the E2E folder. And then I'm gonna pass the V, so verbose. This is obviously, even though test containers is running, what you see here is that it's starting a container. It's then saying like, this is the container was created. We wait for it, we run our tests, and then we terminate at the end. And finally, I know it looks like we terminated the container and then we ran the test, but that's not the case. It's just the way that the outputs come out on the console. Sorry, on the terminal. So the reason that this happens is that the test won't finish until the deferred function runs, and then the test output will come on the terminal. So yeah, I mean, it looks weird, but I'm promising you that this is what's happened because we've waited and then we've cleaned up. I think this is super cool. It's super cool to be able to manage my container inside my test. And it's super cool to not say, oh, you know, please look at the README and see what the setup is before you run your Endtoend test, because otherwise they'll fail. Someone will be like, oh, why is it failing? I ran this. Oh, no, they supply the wrong port. I don't know. All sorts of things can happen. So the management of test containers inside tests, I think, is huge. I wasn't aware of this project until recently, so I was really keen to include it and show it to you as well. Okay, the next thing that we're gonna have, so we've gone all the way through in the test pyramid, in the what you call it, in the testing trophy, but I want to show you one other thing, which is contract testing. So contract testing is not new, but it's gained a lot of popularity in the microservices world. So there's been a lot more interest in contract testing. What is contract testing? The reason why it's really cool is because it allows you to test a consumer and a provider in separation, and also have some kind of communication tool between microservices, which can be developed by different teams that never talk. So in contract testing nomenclature, a consumer issues the request for data. So they're the ones that want something. The provider responds to the request, and they're the ones that are returning said data. The contract itself records the expectations of the consumer and the provider. So the contract will contain like, hey, I'm the consumer, I expect to send you this request, and I expect this response for you, and then from you, and then we verify the provider is behaving according to the consumer expectations. And why is it the viewpoint of the consumer? Why is it the consumer that says like, this is what I'm sending you and this is what I expect? Because normally the consumer will be the one that is the external party. So it's all there. Contract testing is normally also called consumer-driven contract testing, because they are the ones that are recording their requests, recording their expectations, and then the provider has to fall in line. The contract is, as we will see, is just a JSON file. And it allows us to have a common language between these two teams. And it allows us to have something generated that will be the source of truth. And I will show you that that is very powerful. The way we do that, because again, I don't like doing stuff from scratch. I'm very lazy. The Pact tool is another open source project that I'm keen to share with you. And it provides contract testing. It provides a contract testing framework with libraries in over 10 languages. I didn't list the languages here, but you'll be able to find all the major languages. What it does provide you is mocking and verification. So like when we test from the consumer viewpoint, we test against a mock of the provider. And the reason we do that is because we want to record our expectations, but also have the tests run as quick as possible. Normally, where do we store this contract? Do we put it in a GitHub repository? How do we version it? How does it work? The way that I've seen it done, and it is like the best way, is to run a broker. So a broker will say like, this is the interaction. I'll send a request to the broker, say this is the interaction, this is what I want to verify against, this is the version, and then the broker will respond with the contract. So that's kind of like how you might productionize what I'm going to show you. So I'm going to show you some more code. I hope you're not sick of it. So in the contract test, I've written only a very small contract test. So the consumer test will be the get events. And what we see here is I'm going to start a new ephemeral server, and I'm going to say this is the test. What you see here is the DSL, or like domain-specific language, that the Pact library provides. So I can just call things like upon receiving with requests. I don't have to write this common language myself because the Pact library provides it. And this is like also something that's really important, because no matter where you now go, you will have the same nomenclature when you write contract testing between employers, between languages. Once we're finished, this contract test will be saved somewhere, and it will be saved in the local environment. It will be saved here in the Pacts folder. So here you can see here, this is the interaction that I've said on get events. This is the response I expect. And the reason why you will agree that this is very portable between different languages. The contract can look the same, which I think is great, right? When it comes to the provider, I can't test against two mocks, right? Because like, what's the point? Like, I've already mocked you once. Now it's your turn to cough up and see if you match my expectation. So what we do is again, we use test containers, our bezies that we've just met, and we start we start a generic container with the Docker image, and then we run against that. And this will be the test. This test is very similar to what I've already shown you, because it was only the contract that was the important bit. I've done something that was very sneaky and I didn't show you. If we are running, no, it was over here, sorry. If we are running against a remote, which will be my next thing, I'm going to say like, what about pipelines? If we're running against the remote, I will have a broker base URL. So I have a broker somewhere. So again, I'm going to do that with another environment variable. When we run things, this is going to be one of the last things I run. Again, everything is exactly the same. So I'm going to say contract equals true. And then I'm going to go test, and the folder is called contract test, and then I'm going to say verbals. So this is going to start. It takes a while. We check the Pact broker, we see the versioning, and then we test against the real provider. And you see some really nice some really nicely generated output. Like, I didn't write these really nice lines. I just specified them inside my test with those chained methods that you saw. Again, the output will be the same no matter what language you're using. So even though I've demonstrated things to you in Go, if you're using something else, these techniques will still be applicable. The last things I want to talk about is CI/CD pipelines, and I've already said that because I was sneaky and I already set up something about remotes in the contract test. So I think most people will agree that GitHub Actions are now the popular solution for CI/CD pipelines. Do you use GitHub Actions? Yeah. The cool thing about GitHub Actions is that you can use what others have worked and done for you. So I don't like to write stuff from scratch. We've already seen I like using tools. So that's the best thing about GitHub Actions. Normally, we use them as quality gates. So they sit in between the build and the test. So you've pushed your commit to GitHub or whatever you use. And then you will run your GitHub Actions, your test, and then if everything is working correctly, then only then we will push to Docker, and only then we might deploy in the big bad world. Now, sometimes you can have tests in between the pushing of the image and the deployment, but obviously I have only a very small application, so I've decided to skip that. So I'm going to show you what the GitHub Actions might look like. So when it comes to just testing on any push when I run my tests on all branches, we've already said that I only want to do the fast feedback loop. So you see, I check out, this is the way we set up things in Go. So we set up Go, I check out the dependencies. Go 121 is the newest version. That's why I've put the Go version to 121. Then we build and then we test things. In Go, we also have this thing called the Golang CI, which is the linter, and it'll be able to find any style errors. Like style is something that's very well prescribed in Go, so we'll be able to have default tooling that will be able to do that. When it comes to, let's say now I want to push to main, so I want to be a little bit more stringent. I've pushed to the main branch instead. At this point, I want to run integration tests. And what do? I do the exact same thing as I've done before. I set up Go, I check out my repository, and then I run with the integration environment variable set exactly like I did in the console. But I also want to show you now exactly what's happening with contract test and end-to-end test. So I've got some environment variables, which are my packed broker base URL, and I will also have a token, which will allow me to authenticate my GitHub Actions against my user or my packed user. At this point, once I've built everything, so I know that things are maybe passing on main, it's time to log into Docker Hub, extract metadata, and then push my Docker image. Once I've pushed the Docker image, so I push the Docker image first, which I can specify ordering with this like needs on line 46. Once I've pushed that, I'm like, okay, this is the new Docker image. Let me run my end-to-end tests, and we know that I use test containers with the Docker Hub image. And then finally, because the consumer also depends on the Docker image, I will say, okay, run the contract tests as well. So you'll see that installing packed is a bit of a situation. So I do use curl to install it. You will find other already built GitHub Actions. You will have other options to be able to do that. And then once that's set up, I can test it and do it exactly the same way that we've done before. Once the consumer runs, I can publish the packed file. So that'll be the new packed, the new contract that I've said will be the way. And I will be pushing it to something called packed flow, and then I will run the provider test. So let me show you what packed flow is. I think it's great. Deploying a broker is actually not difficult. They provide a Docker image, and then you can run it in your work environments, in whatever staging environment you might have. But obviously, like, maybe I don't want to do that just for a demo. So what they provide is packed flow. So they can run the broker for you, and then you can push the contract up against it. And when you run the provider, you can use this URL that will return you the packed from the newly published image, not what I checked into my repository. In fact, my packs should generally be git ignored because you should run them. You should generate them as part of your CI/CD pipeline. And then they're able to like build this really lovely user interface and then respond with the expected responses. So what you see here at the top is the packed flow URL and then the version that I would be requested, which is version 1.2.3, because that's what I wrote in my CI/CD pipeline. I'm just going to show you this very quickly. So one of the things that you can do, I told you we were talking about ordering of images. So this is quite small, but you can see here that I've ordered, push to the Docker image, run the consumer, publish, and then run the provider, and the end-to-end tests are running as well. So this ordering is important because we don't want to run against an old version or any of that. So GitHub Actions is a great way to reuse things that others have done, as well as make it easy for you to order in things in YAML. So I think it's really great, and I can definitely understand why they've become the standard of CI/CD pipelines. So I've showed you a lot of things. I hope you found them useful. In summary, developers should write tests at all levels. So try and challenge yourself to come out of the bread and butter that are unit tests. As I've shown you, there's lots of tooling that we can use in a lot of languages that will allow you to write tests in the same way that you write backend code. I think this is, if you take anything away from me talking today, is remember you have tooling that allows you to use the same backend coding techniques to write tests at all levels. Use tests as your quality gates, prevent outages, prevent those nasty bugs, prevent you spending all your time fixing these bugs. And in particular, if you embrace writing different types of tests, you'll be able to make better assertions around the behavior of your microservice architectures. But most important, embrace a testing and quality culture in your teams. Ask yourselves, why should tests come last when they actually help make your lives so much easier? Like, think about how much time you'd have to test. Also, I'm a person that really doesn't trust myself, and this is probably why I really go into testing, because I want to prove to myself that the code I wrote is working. So that's all I've got for you today. I'm Adelina. I hope you really enjoyed this session. I'll be around the rest of the day, and also I think we have some time for questions. Thank you. If you're shy, you'll be able to find me later, so definitely, yeah.
When you do the fuzzy testing.
The what, sorry?
The fuzzy testing?
The fuzz testing.
Yeah. Is it like the same sequence of test parameters that it'll generate from each run?
No.
So you don't necessarily know that if you test once, then it'll pass and...
Yeah, so flakiness in fuzz testing is something we shouldn't throw away, right? But if things were to fail, you'll be able to see exactly what's gone wrong. Code robustness is something that I should have talked about more maybe, but I think it's much more important to cover code in today's world. It's super important to cover code robustness alongside edge cases. Also, I don't know if I was quite surprised. You know what the difference between a corner case and an edge case is? So an edge case happens at the extremes of one parameter, and a corner case happens at the extremes of multiple parameters. Yeah, I use them interchangeably, but the more you learn.
What is your experience of the efficiency of finding bugs with packed? So how many bugs do we find in packed versus earlier stages with unit testing or later stages with end-to-end testing?
That's really a great question. What we've seen from experience in production is that they really work well with especially event-driven architectures. So event-driven you'll be able to support, like, this is the response, and you'll be able to really see what's going on in your data exchange. I think, especially in convoluted systems, like we were talking about earlier, like really difficult to test systems, contract testing shines over end-to-end tests because of this separation where you can run against the mock and then things will become much faster. At the same time, the contract is only as good as the test. While in end-to-end testing, you might be able to do a lot more variety of specifications and like really see maybe synthetic monitoring or things like that. We use it a lot. Everywhere I've worked, we've used it a lot, especially to monitor against third parties that we don't maybe trust. So you can say to them like, hey, all of a sudden this test is failing, and you can test it also at large volumes, which will move the needle when it comes to costs if you were doing it in end-to-end testing. That's kind of my experience. I hope that answered it.
You mentioned in the test containers that you passed it like a pre-built Docker image on Docker Hub.
Yeah.
But you might want to like run those integration tests to like verify everything is okay before you ever publish something as an artifact.
Yeah.
Is there any way to like give it your Docker file or anything? Like maybe have a Docker Compose even?
Yeah. So integration tests don't run against the Docker file. They run against just the handlers, the code that I have. But yes, you might want to do it before publishing to Docker. You can give it a Docker file. But what I find is that the Docker Hub can have versions that are not ready. So I don't think it's the worst idea to push to Docker and then maybe test and deploy later. You maybe don't want to do. What I've seen often is that deploys are manual. So like deploys. So you'll be like, okay. Not manual, but you'll commit another PR to say like bump this version after you've asserted that everything is working. So I think it's okay to have like random versions going around in Docker Hub. Huge thank you, and thanks for sticking with me.